Pringles Crisps, potato-based dough precision, 16 manufacturing stages, shipped to over 140 countries worldwide.
Inside this modern facility, production runs continuously, combining precision engineering with robust automation across line modules.
Today, we follow the complete journey from raw potatoes to stacked, sealed crisps ready for shipping.
Truckloads of potatoes arrive, weighed and sampled, each batch logged for full farm-to-can traceability.
Automated samplers test solids and quality, ensuring only suitable potatoes enter the flake production stream.
Digital traceability links every truck and field to its final crisps, supporting consistent quality and compliance.
Automated distribution balances throughput across lines, protecting equipment while maximizing stable, continuous production rates. From this point forward, every potato is guided by carefully engineered systems toward uniform, stackable crisps.
High-pressure wash systems remove soil and debris, reclaiming water to reduce overall consumption and waste.
Hydraulic flumes and destoners separate rocks from tubers, protecting cutting blades and downstream equipment from damage.
Optical sorters scan every potato, ejecting defects in milliseconds to maintain tight quality specifications.
Final surface cleaning prepares tubers for peeling, minimizing peel loss while improving downstream product appearance.
Clean, sorted potatoes now advance to peeling, entering the controlled, hygienic core of the production line.
Steam peelers rapidly loosen skins, while engineered condensers capture heat, improving overall thermal efficiency.
Mechanical finishers strip residual peel, directing potato skins to animal feed or biogas rather than landfill.
Sampling verifies peel quality and defect levels, feeding statistical control charts that stabilize upstream parameters.
Blanching inactivates enzymes and stabilizes color, precisely controlled by temperature, flow, and conveyor speed.
Dewatering after blanching protects mash consistency and reduces unnecessary energy use in later drying stages.
High-speed dicers deliver consistent particle size, essential for even cooking and uniform flake properties later.
Inline metal detection protects both equipment and consumers, forming a key checkpoint in food safety.
Steam cookers bring every cube to target core temperature, ensuring thorough gelatinization without structural collapse.
Cooked cubes drop directly into mash kettles, where solids and moisture are balanced for ideal drying behavior.
Regular lab checks confirm mash properties, preventing off-spec flakes and safeguarding downstream dough consistency.
Industrial mashers create a homogeneous potato slurry, critical for even thin film drying on the drums. Steam-heated drums flash off water, transforming potato mash into delicate, low-moisture sheets within seconds.
Controlled film thickness and breakage patterns help deliver stable flake size for later dough formulation.
Milling refines dried sheet into standardized potato flakes, tailored to absorb water predictably in dough mixing. Finished potato flakes enter hygienic storage silos, buffered for continuous, high-volume, crisp dough production.
Automated dosing systems combine potato flakes, starches, and water, building a controlled base dough for crisps. High-torque mixers blend to a uniform texture, ensuring every batch behaves identically on the line.
Automated cleaning cycles protect food safety, preventing cross-contamination between recipes and production shifts.
Closed augers deliver dough to the sheeter at controlled rates, stabilizing line speed and thickness.
A preforming roll levels the dough, preparing it for precision compression into a continuous sheet.
High-pressure rollers flatten dough to consistent thickness, critical for even frying and texture later.
Inline sensors monitor sheet thickness continuously, correcting drift before it impacts frying performance. Edge trims recycle back to mixing, reducing waste while preserving the uniformity of the central sheet.
Rotary cutters punch thousands of identical ovals per minute, defining the footprint of every Pringles crisp. Vacuum-assisted transfer keeps each dough oval correctly oriented for precise placement into forming molds. Curved metal carriers cradle the dough, giving crisps their engineered saddle shape during frying.
Precise forming ensures every crisp shares the same curvature, improving stacking, strength, and mouthfeel.
AI vision checks every mold, removing defects before frying to maintain yield and visual consistency.
Multiple forming lanes merge into a single high-capacity fryer, engineered for continuous, stable throughput.
Precisely controlled fryers await the formed dough, ready to drive off moisture and lock in structure.
Dough ovals fry for seconds in hot oil, moisture flashing off to create a crisp, porous structure.
Continuous filtration keeps frying oil clean, stabilizing color, flavor, and oxidation across long runs. Emerging from the fryer, crisps show uniform golden color, a visual confirmation of controlled heat transfer.
Air knives reduce surface oil, improving texture, nutritional profile, and packaging cleanliness for each crisp.
As crisps cool, their final geometry and crunch stabilize, preventing warping before seasoning and stacking.
Inline moisture checks ensure every crisp reaches low water content, extending shelf life and preserving crunch.
Cooled crisps now divide onto flavor lines, ready for precise seasoning that defines each variety's character. Rotating drums gently tumble crisps, exposing every surface for an even, repeatable seasoning layer. Gravimetric feeders control seasoning dosage by weight, balancing flavor strength with cost and nutrition targets. A light oil mist improves seasoning adhesion, enhancing flavor distribution without significantly increasing fat content. Dust extraction protects workers and equipment, capturing fine seasoning particles before they reach the wider plant.
QC checks confirm target coverage and color, linking visual appearance directly to seasoning process parameters.
Seasoned crisps spread into shallow layers, minimizing collisions and protecting the fragile curved geometry.
Metal detectors provide another critical safety barrier, ensuring foreign metal cannot enter finished canisters.
Intelligent diverters distribute product evenly, keeping every canning line supplied without overloading conveyors. Vibratory lanes singulate seasoned crisps, aligning their curves so stacks form cleanly in the canisters.
Counting sensors track every crisp, matching product flow to precise piece counts for each package size.
Servo-controlled stackers build columns of crisps, their identical shape enabling tight, protective nesting. Air pulses settle each stack, eliminating voids so every can delivers a tidy, uniform tower of crisps.
Vision-guided rejection removes misstacked columns, protecting the consumer experience and brand presentation.
Printed paperboard blanks roll into rigid tubes, forming the iconic Pringles can ready to receive stacks.
Base ends are seamed onto each tube, creating a robust canister foundation for the delicate crisps. Pre-built stacks drop into each can in a single motion, minimizing breakage and handling stress.
Stack geometry matches can diameter exactly, limiting movement and protecting crisps from impacts in transit.
Check weighers confirm correct fill weight, guarding both regulatory compliance and consumer value perception.
Sealed foil membranes protect crisps from oxygen and humidity, extending shelf life far beyond open chips.
Snap-on lids add reclosability and branding, completing the recognizable Pringles package, leaving the filler.
High-speed coders mark each can with batch and date, enabling full traceability from pallet back to line.
Automated carton erectors build cases on demand, forming the outer shell for transport and shelf handling.
Grouping systems arrange cans into precise patterns, maximizing case space and protecting product during transit.
Case sealers lock cartons closed with controlled adhesive, securing stacked cans against shifting and impact.
Printed shipping labels encode product and destination data, feeding warehouse and customer systems with live information. Robotic palletizers stack cases with millimeter precision, building stable loads tailored for each customer channel. Powered conveyors move finished pallets automatically, minimizing forklift traffic around critical production areas.
Stretch wrapping secures each pallet, protecting canisters from vibration, dust, and moisture on long journeys.
Pallet labels carry standardized logistics codes, connecting each stack of cans to global warehousing networks.
Electric pallet movers reduce emissions inside the plant, feeding pallets into the automated storage system.
Automated high bay warehouses buffer production, matching continuous output to fluctuating global demand.
Warehouse software tracks every pallet's location, supporting first expiry, first out rotation and rapid order picking.
Order picking algorithms group pallets by route, consolidating loads for national and international distribution centers.
Loading teams follow digital dock plans, sequencing pallets so retailers receive mixed flavors exactly as ordered.
Final scans close the digital loop, recording every pallet's departure time, route, and carrier details.
From here, pallets travel to regional hubs, wholesalers, and retailers, supplying Pringles lovers in over 140 countries.
Centralized planning balances production, inventory, and transport, ensuring steady shelf availability worldwide.
Each can's journey from potato to pallet typically takes around 20 minutes of streamlined processing.
Laboratory teams monitor oil, seasoning, and product parameters, verifying safety and consistency beyond inline checks. Offline moisture tests validate inline sensors, tightening control over texture, shelf life, and frying conditions. Microbiological surveillance confirms hygienic conditions, supporting compliance with international food safety standards.
Trained tasters score crispiness and flavor, ensuring each batch matches established sensory profiles.
Packaging integrity tests verify seals and structure, protecting crisps from oxygen ingress and mechanical stress.
Central dashboards bring together quality data, supporting rapid decisions and continuous improvement on every shift. Energy programs target lower emissions per can, aligning snack production with science-based climate commitments.
On-site treatment systems clean process water, enabling reuse and reducing the factory's freshwater footprint.
Potato byproducts are diverted from landfill, repurposed as feed or energy feedstock in circular systems.
Packaging engineers balance protection, shelf impact, and recyclability, reducing material use per serving over time. From optimized fields and factories to this moment, every stage safeguards the familiar Pringles experience.
Behind each crisp lies engineering, quality, and care, transforming simple potatoes into a global snack icon.